Students, our next topic is electric field. When a charge Q naught is held in vicinity, it means when a charge Q naught is held near another charge Q, then this charge Q naught experiences a force of attraction or a force of repulsion. We say that this force of attraction or repulsion, this is due to interaction of electric fields of charge Q and Q naught. Therefore, electric field may be considered as the space property by virtue of which presence of charge Q modifies the space around the charge. By virtue of which this charge Q exerts a force on any other charge which is brought in this space. Let us start once again. When a charge Q naught is held in vicinity of charge Q, then this charge Q naught experiences a force of attraction or repulsion. We say that this force is due to interaction of electric fields of Q and Q naught. Therefore, electric field of a charge Q is the space property by virtue of which presence of charge Q modifies the space around the charge, leading to development of force on any other charge which is brought in this space. Therefore, we may define electric field due to a given charge is the space around the charge in which electrostatic force of attraction or repulsion is experienced by any other charge due to the given charge. Electric field due to a given charge is the space around the charge in which electrostatic force of attraction or repulsion due to this given charge is experienced by any other charge. If at a point charge experience no force, if at any point this test charge experience no force, then at that point electric field must be zero. If at a point test charge experience no force, then electric field at that point must be zero. The concept of electric field was first of all given by Faraday. Now the charge Q which is producing the electric field is called source charge, and the test charge which tests the effect of source charge Q is called test charge. The charge capital Q which is producing the electric field is called source charge, and the charge Q naught which tests the effect of charge capital Q, this is called test charge. The electric field, this may be due to a single charge, or this may be due to a group of charges, or this may be due to a continuous charge distribution. Now our next topic is electric field intensity. Electric field is measured by the quantity called electric field intensity. Electric field is measured in terms of electric field intensity. Electric field intensity at a point, electric field intensity at a point measures the strength of electric field at that point. Electric field intensity at a point measures the strength of electric field at that point, or electric field intensity at a point, electric field intensity at a point in electric field, at a point in electric field is force experienced by unit positive charge placed at that point. If let us suppose that we have a source charge, and let us suppose that at this point we have placed a test charge Q naught. If F is force experienced by test charge plus Q naught at a point, at any point whose position vector is r vector, if F is force experienced by a test charge Q naught at a point whose position vector is r vector, then electric field intensity at this point whose position vector is r vector, this will be F upon Q naught. Because F is the force experienced by charge Q naught. Charge Q naught experience a force F. Unit charge will experience a force F upon Q naught. Fr mean force experienced at a point whose position vector is r vector. Therefore, electric field intensity at a point with the position vector r vector, this is force experienced by test charge Q naught upon Q naught. SI unit of electric field intensity is Newton per Coulomb, because unit of force is Newton, unit of charge is Coulomb. Further, electric field intensity is a vector quantity. Electric field intensity is a vector quantity. The direction of electric field intensity is the direction of force F. Now the direction of force is the direction along which test charge Q naught moves if it is free to move. If this charge is positive and this charge is positive, then it will experience a force of repulsion. This gives the direction of force. This gives the direction of force. And if the test charge is negative, then this experience a force of attraction. So this is the direction of force and direction of electric field intensity. Now electric field due to positive source charge, this is directed radially outward, and electric field due to negative source charge, this is directed radially inward. Now as we have studied electric field intensity at a position vector r, this is Fr upon Q naught. As test charge Q naught may have its own electric field, which may, as test charge Q naught may have its own electric field, which may modify the electric field of charge Q. Therefore, to minimize this effect and ultimately remove it, we define electric field intensity at a point with position vector r is Fr upon Q naught, limit Q naught goes to 0. When Q naught becomes smaller and smaller, electric field intensity at a given point, this is defined more accurately. Now, due to discrete nature of charge, Q naught cannot be 0. The minimum value of charge, this can be 1.6 into 10 raised to power minus 19 coulomb. But on macroscopic scale where charges are very, very large, then it is as good as taking limit Q naught goes to 0. If the test charge is positive, then electric field intensity at that point is somewhat less than actual value, and if the test charge Q naught is negative, then electric field intensity at that point is somewhat more than actual value.